Hey everyone, let's start our Unit 3 full review. So I'm starting with some notes. Pause the video, copy these down, and I'll quickly go through each one, and we'll start all the odd problems together. Okay, so these notes are really important to commit to memory because so many of the FRQ problems are based on these concepts. So you need to know when f is increasing, that means that the slopes or the derivative is greater than 0. That makes sense. The slopes are positive. Going backwards, that means our function is increasing. Similarly, if the derivative is less than 0 or negative, that means that our original function is decreasing. So in this graph over here to the right, f of x is increasing when the slopes are positive. So f of x would be increasing for all this region, from a to c, and then from c to positive infinity, since f prime is positive, aka above the axis. The original function would be decreasing where the derivative is less than 0, and the derivative is less than 0 here, so the original function would actually be going down. All right, moving on. F of x critical point, know the two possibilities. Either the slope equals 0, so you have a horizontal tangent line, or the slope does not exist. In this case, we would have like a sharp corner. So here are different ways that you have a critical point. A horizontal tangent line like there, or a sharp corner where the slope does not exist. F of x has a relative max where f prime changes from positive to negative. So that means that the slopes were positive and then the slopes became negative. We have a relative min when our slopes change from negative to positive. And then we have, in general, relative extrema, meaning either of these, anytime we switch signs. So it could be increasing then decreasing, or decreasing and then increasing. For concavity in this final section, we're dealing with the second derivative. So know that when we're concave up, the second derivative is positive, greater than 0. Okay, but another definition is for f being concave up is that the derivative itself is increasing. So coming back to our graph at the top, I would know that f is concave up where f prime is increasing. So from here to here, that's where the graph is concave up. So f of x is concave up since f prime is increasing. If, however, I'd given you a second derivative graph like this, and let's say I use the same one, then you'd have to use the definition, which is the second derivative is greater than 0, and that would be true only from here to here. So commit both of these definitions to memory. If I give you the second derivative graph, you're looking above the axis. If I give you the first derivative graph, you're looking to where it's increasing. Okay, concave down, the second derivative, f double prime, is negative, less than 0, or the first derivative is decreasing. And then finally, we have an inflection point on f when f double prime equals 0 and it has to switch signs. So this is basically saying it switches from being concave up to concave down, or vice versa. So this is an inflection point. I'm cup down, then I'm cup up. Or I'm cup up, then I'm cup down. These are my inflection points. Now, using the first derivative definition, we would say it's where f prime switches from increasing to decreasing. So for instance, this would be an inflection point since f prime changes from increasing to decreasing. And then this would also be an inflection point since the first derivative changes from decreasing to increasing. Okay, so that's just a basic rundown. Let's start number 1. So state the interval over which this function's increasing. So let's show our work. Actually, let's first write the definition we need. If I want f to be increasing, that means that f prime should be greater than 0. My slope should be positive. So let's find f prime of x. And then let's see where it's greater than 0 by using a number line. I will have to factor and reorganize these. Factor out the negative when it's in front, always, and an x. Let me check my work. So it's going to be negative 12x cubed plus 2x. Looks good. I'll continue by factoring using difference of squares for the second term. So that'll be root 6x minus 1 times root 6x plus 1. And now let's take this on a number line by finding our roots. Okay, on to my number line. I see that I have 3 spots, 3 critical points. Right? These are all critical points because the derivative equals 0. On the right, I'm starting negative, and all of my exponents are odd, so I'm going to flip all of these signs. Okay, we want to know where f prime is greater than 0, so our answer will be negative infinity to negative 1 over root 6, and then 0 to 1 over root 6. You also have to write an explanation because it's going to be 2 points on the AP exam. 1 point for the answer, then 1 point from the explanation. Your explanation would be f of x is increasing on this interval since f prime of x is greater than 0. Okay? Try to yourself.